these Cretaceous succession of Spain, and then the lower left one representing some dolomite bodies which are been associated with limestone, so interbedded limestone and dolomite. The light gray color representing the dolomite beds, whereas these gray color representing off-white to gray color representing the limestones. The outcrop, which is in the bottom right, representing vertical beds of interbedded limestone and dolomites. So this is a teamwork with my students, master students and PhD students, worked on these various outcrops. Hamad Rahim, who is a PhD student, just completing his PhD very soon. And thank you for the analytical work in University Autónoma de Barcelona, where Hamad visited for 6 months, and also University of Barcelona, where he carried out some of the studies. Awsaf Hassan, he had worked also on some of the outcrops, and Arif, he was also involved, my master student, during these studies. So in terms of the location of these outcrops, it's part of the foreland thrust belt. We can see over here these major fault systems in the northern part of Pakistan, where we have salt range in the south, MBT in between, and we have the MMT more towards the north. So this study area is located in between along the MBT, I would say, and we have multiple sections which we had measured and we had studied. So different locations, 1, 2, 3, 4, 5, had been studied in the present, which I will present in this particular presentation. Stratigraphically, Jurassic succession, Upper Jurassics, which are mostly dominated by limestone and dolostone interbeds, and these limestone and dolostone interbeds are containing oolitic facies, which typically represent ramp environment of deposition of the host limestone, which had been dolomitized later on by later diagenetic processes. So this is the sections which had been measured in various localities as 1, 2, 3, 4, 5, representing as Mira Rahmat Khan, Baragali, Shala Ditta, Ormeana, and Sirk sections. This is the one of the outcrop which had been studied extensively, named as the Mira Rahmat Khan outcrop, where we can see in the upper aerial photograph, we can see panoramic view of the outcrop, where the dolomite bodies, you can see these.
Excuse me, sir. We cannot see the slide, sir. Okay.
Oh, really?
Yeah. Now it's okay.
We are stuck on the first slide.
Now it's okay.
Yeah. Now we can see the outcrop now. Yeah.
Okay.
But I am still on the first slide.
Is it okay now?
Yes, it's okay now.
Okay.
No, it's not. I am currently on the title.
Yeah, we can see the logs, the slide where we have the sedimentological logs.
Okay, so I'm on the next slide, which is representing the field observations, showing the aerial view of the outcrop section of the Mira Rahmat Khan. So if you look at this particular outcrop, we can see that these have excellent bedding parallel dolomites which are being interpreted as in some cases layer parallel or bedding parallel, and in some cases we have these faults, normal faults, which can provide some open spaces for formation of for the generation of these dolomite bodies. Then the second outcrop is the Formiana outcrop section, where we have excellent example of having different facies in terms of limestone as well as the dolostone, which ranges from coarse, very coarse grain granular limestone to the very fine grain mud dominated limestones. Where we observed various dolomite facies as well, like burrowed dolomite, dolostones, patchy dolostones, bedding parallel dolostones, and then on the top we have another episode of patchy dolomite horizon as well. So we can see, we'll look into it in much detail, but an aerial view representing these various successions being present on top of each other. Then the third outcrop, which is Baragali and Shaladita sections, which represent the thick sequence of these limestone dolostone bodies interbedded with each other. So coming back to the field observation in detail to look that dolomite bodies been present in the Mera Rahmat Khan section, which had excellent outcrop succession, and we can see that these dolomite bodies are basically being interbedded with the host limestones. So we have stratiform or layer parallel dolostones, and in some cases some patchy dolomites can be observed as well. This is another example of showing the dolomite bodies being associated with the weak zones like bedding surfaces and these stylolytic surfaces. What had been discussed earlier, that these surfaces are the pathways where the fluids may percolate, and we can see over here that in various photographs, outcrop photographs, we can see that these dolomites are extensively being associated with bedding surfaces as well as the starlight surfaces, where we can see over here as well. Some patchy dolomites, which are also termed as burrow-filling dolomites, which can be seen over here. We can see that the isolated burrows, they are being filled by this brownish color dolomite, which can be seen over here as well in the cut section, and that represents the presence of these dolomite in isolated burrows as well. Fracturing and brecciation, sometimes it's difficult to associate it with the brecciation, because over here we can see that these clasts, which are well rounded to sub-rounded, they are being floating in the dolomite matrix, which is again a question mark regarding the formation of such kind of process, or the process being involved in the formation of this particular brecciated, or I would say it angular to sub-rounded kind of material. Some more outcrops where we have the pervasive dolomitization can be observed over here, and we can see a thick dolomite and then the thick limestone being present over here. Similarly, in this particular succession as well, we have dolomite which is underlain by the limestone succession, which indicates the presence of interbedded limestone and dolostone succession in the study area. Beside the dolomites, we have calcite filling veins that had been observed, which post-date the these dolomite succession, and we can see that these are basic. They are also acting as a pore filling, so fracture filling, and in some cases they act as a pore filling material as well. So various examples of calcite filled cements can be observed as fracture filling phenomena. Similarly, over here, some white colored calcite, and we have the saddle dolomite, which has been present along the border of the pores. Very clearly can be seen over here, where we have this particular brownish color dolomite, and in between this white color dolomite we have this calcite, which is filling the rest of the open space. We can see it over here. We can see it over here also.
Mumtaz, I can only see slides with the fracturing and brecciation, and there it stopped.
Oh. Really? Okay, I go back. Maybe I think we have some issue with the speed of the internet. Maybe. So now, where are you?
The slide with the fracturing and brecciation filled by dolomites.
Okay. Okay, this one. So I go to the next slide, pervasive dolomitization. So I wait for a minute to this slide may be transmitted to you. The title is pervasive dolomitization.
No, it stays by the fracturing.
Oh, let me go back and then again share it. Okay. It's still there?
Still fracturing and brecciation. I don't know if the others can see the other slides, but
we see the same fracturing and brecciation.
Yeah.
So no
I myself is seeing the fracturing.
Yeah, pervasive dolomitization now.
Yeah, it's okay.
Okay.
Yeah,
I will be a bit slow to go further. Okay. So here we can see some dolomitization, which is where in the outcrop section we can see a thick dolomite body, and then on top of it we have these limestones. But in the close-up view, we can see that these dolomites have the class of the host limestone as well. And similarly, we can see interbedded thick limestone followed by the dolomite in the outcrop as well. So I go to the next slide. Fracture filling calcite. Is it okay? I'll wait for a while.
sir, maybe you can try to off your video. That can reduce the speed error and.
Okay. How do you like this? Okay. Maybe I have opened so many things, so that's why the speed may be a bit slow. Okay. Now I'm on fracture filling calcite. So can you see this slide?
No.
No.
Still pervasive dolomitization.
Oh. Okay.
Strange.
Yeah. I will try to transform it into PDF, and then I will do it from there.
PDF
I think that
will
would be more practical.
Yeah.
Mm-hmm.
Maybe you can close the presentation and open it again.
Yeah, okay. You can see now the PDF. No.
We see the pervasive dolomitization slide.
Okay. I'm opening it again.
Okay. Now we see all the slides.
Okay.
Okay. Outcrop observations.
Okay.
Okay. Yes.
So I'm on pervasive dolomitization.
Yes.
Once you get it, it's okay now?
It's okay. Pervasive dolomitization.
Okay. So I go to the next slide. Fracture
Okay.
penning calcite.
That's perfect.
Okay.
Yeah.
Yeah. Thanks. Sorry for a bit interruption. Here in this particular slide, we can see that we have multiple sets of fractures which are being filled by calcite, and these calcites basically are younger than the dolomites. What we can see over here, they are cross-cutting these dolomite bodies, so they represent late stage of their formation. Similarly, the saddle dolomites, which we can see over here, the brown color representing the dolomite, and in multiple outcrop photographs, you can see that these brown color is representing the dolomites, whereas in between the brown color we have these calcite in between. The white color, off-white color, is represented by calcite. So these are the late stages of their formation. So we will confirm them by knowing their paragenetic sequence later on. The host limestone, which is mostly oolitic, pelloidal, having micrite cements, and they have, we can see a typical example of the oolitic and the bioclastic nature of these limestones, which represent their original texture of the host limestone. With some terrigenous material, we can see in some of the photomicrographs which represent late stage influx of terrigenous material. A bioclastic nature, which is indicative, typical characteristic of this particular limestone, with some early dolomite formation. We can see these rhombic grains of crystals of dolomite. We can clearly be able to see. This is the detailed facies log of the Samana Suk formation in one of the lithology, which represent inner ram to shore or bar related formation or depositional environment of this particular Samana Suk formation. Some early diagenetic phenomena which can be seen over here, associated with micritization, then the dissolution of the micrite. Then some marine cementation can be observed in the lower part of these photomicrographs. Then we have the neomorphism, some early stages of marine diagenesis. We can see styrolites are typical in such limestone successions. We can see multiple sets of styrolites, which is which we can be able to see how this particular stylolite is basically cutting the ooidal grainstone facies over here. Then the matrix dolomite, which is present, is fabric destructive. So we can see a nice contact between this matrix dolomite and the host limestone, and that can be observed as well in the CL photomicrograph. Similarly, coarse crystalline matrix dolomite, which is MD2, showing the cloudy appearance as well, and we have some more coarser grain sucrosic type of dolomite can be observed in figure E and F. Some other dolomite types, as we have seen in the outcrop, that the burrows, they are being filled by this brownish color material, which is evident that over here in figure A, these brownish colored material is basically the dolomites, which are basically filling the open spaces over there. In figure C and D, we have these fecal pellets which are being present within the burrows. They are being encrusted by the phosphate coatings, which is evident under the CL microscopy. Some nice examples of how partial replacement of the host limestone can be seen over here, where the replacive dolomite cement can be seen, and this typically represents that the dolomitization, this particular phase of dolomite, occurred after the initial stage of microtization, where we have the calcite cementation being present over there as well. So partial replacement can be seen over here. Similarly, the burrowed filling dolomites, they are very clear in this particular photomicrograph C, where the isolated burrows, they are being filled by the dolomite crystals, and we can see the same in the case of under the CL microscopy as well. Typical example of saddle dolomite, where we have these saddle dolomites having much more bigger crystals, which typical undulose extension, what we can see over here, and it is cementing the pore in this particular case. Similarly, in figure B, we have the similar nature of these saddle type of dolomites. In figure C, we have C and D, which is representing the polarized microscopy, and the CL microscopy representing the growth of these dolomite crystals, and the open spaces are being filled by the calcite, which can be observed under the CL, where we have the dull luminescence orange color is represented by calcite. Similarly, we have these pore fillings, cavity fillings, where the saddle dolomite is being filled, what has also been observed on the outcrop scale, and we can see that the remaining central part that had been filled by the calcite. Late diagenetic phases, they are being represented by pyrites, which are typical of such kind of dolomite associated phases, where pyrites can be seen over here, and they represent the most latest phase of diagenetic event, where we can see that these pyrites, they are rhomboidal in nature, and they represent the late stage replacive diagenetic phase in these particular successions. Some phosphate mineralization is also been observed, where this blue color is typical of phosphate, and we can see that the phosphate is being associated with the dolomite. Beside these major phases of dolomites, we have some other calcite phases as well, like the typical late calcite phase, which is cross-cutting the dolomite phase as well as the early calcite phases, and then we have these particular calcite phase which is represented as CC3, the white calcite phase, which is basically the most later phase of calcitization in these outcrops. Beside these various phases of calcite and dolomite, if we look at this particular outcrop photograph, where we can see clearly the cross bedding phenomena and the limestone, the dolostones, they represent these cross bedding phenomena where we have a contact with the underlying succession, where these bedding parallel stylolites, we can see over here, they are being filled by these brown color material, which is representing the dolomites. So the typical character of bedding parallel stylolites, the cross stratification, which is representing the shallower water conditions in terms of deposition of these carbonate successions. We have some other characteristic features, where the cauliflower calcite, that is represented as CFC, which is also present in these host limestones, and the CL photomicrograph basically shows stringes of these anhydrides in the calcite as well. Some more examples of completely replacing the host limestone, where we can see that the nice rhombic dolomites can be seen over here, and these rhombic dolomites are being affected by the process of de-dolomitization. So de-dolomitization is quite common, and we can see over here that the rims of these dolomites, they are being obliterated by the process of de-dolomitization. Similarly over here as well, and we can see the same mechanism of de-dolomitization in these more coarser grained dolomite phases as well, where it had been affected by the process of de-dolomitization. So based on the field observations and the petrographic studies, this detailed paragenetic sequence had been established, which represent the eugenetic followed by burial associated and then telogenetic phenomena, where various phases had been identified, and they represent they are well correlated with the events with these particular stages, like the early diagenetic stages, where we have these dolomite and calcite cementation as matrix dolomite, followed by the mechanical compaction and saddle dolomite formation in the burial stages, whereas the late stage phenomena are being interpreted with the fracturing, dissolution, calcite cementation, and de-dolomitization. Some mineralogical studies with the XRD data had been carried out to look at the constituents in terms of their mineralogy. SEM with the EDX data, they are also confirming the various reserves that had been shown in the petrography, where we observed some phosphates, then the dolomites, they had been confirmed by the EDX, then the pyrite grains class that are being present. So the EDX studies further confirm the presence of various phases being observed in the petrography as well. Isotope data, which is very crucial in terms of better understanding the nature of these dolomite bodies. They are well depleted in terms of from the Jurassic marine signatures, where we have the matrix dolomite. It is well within the range of the Jurassic marine signatures, but the rest of the dolomite phases, like the even the limestone, that they have been affected by the flutes, and we have the effect of the replacive dolomite as well as the saddle dolomite and the late stage calcite cements. They have been they represent depleted delta 18 signatures, which represent that they are being affected by the solutions with their and they had been formed at higher temperature as compared to the matrix dolomites. Similarly, the comparing the stable isotope data and plotting them on the using the land equation of 1983 and Friedman and O'Neill 1977, where fractionation by using their fractionation equation, we are able to determine that the calcite, which is the dolomite, which had been formed, is basically related to the magmatic the saddle dolomite that had been affected by some magmatic source, and whereas the matrix dolomite, they represent marine diagenetic phenomena based on this cross plot, what we can see over here. Furthermore, the strontium isotope analysis had been carried out, and strontium isotope data, it reflects that the saddle dolomite is more radiogenic as compared to the other phases, where we have the replacive dolomite and the matrix dolomite. And if we put on the curve where of the MacArthur 2004, we can see that the saddle dolomite, it has very high values in terms of strontium, whereas these replacive dolomites, they are well within the range of the basinal flutes, whereas the other matrix dolomite and the other calcite phases there, and matrix limestone, which that represent its formation on on the curve. So this indicates that we have multiple stages of dolomitization, where the matrix dolomite, they have been formed well within the marine conditions, whereas the saddle dolomite and the replacive dolomite, they had been formed by some external source of fluids which had been responsible to form these two phases of dolomites. They have been further confirmed by the analysis, major and trace element analysis, where we have carried out using the electron microprobe. Ahmad did this work back in Barcelona, where he had been able to look at various phases and ultimately their corresponding elemental signatures. Similarly, transact along the replacive dolomite cement can be seen over here, where we have the high manganese contents in figure B, and we have high calcium to magnesium in figure A. This is a cross transact along across the calcite vein, and that represent the signatures of mixed signatures in terms of lead, which is significantly high in this particular case, whereas we have high signature of barium as well in figure B. So this is a cross plot representing the presence of various major and trace elements of various diagenetic phases that had been studied in terms of weight percent and ppm. in the various studied samples carried out by Hamad in Barcelona. Then it comes to the fluid inclusion data, where we have he carried out two samples, two phases studies of saddle dolomite and the calcite, and based on the fluid inclusion data, which represent the maximum temperature range of around 189 up to 189 degrees for the saddle dolomite, whereas for the calcite it is around 100 degrees. So the histogram of the homogenization temperature shows the range of diagenetic phases, where small proportion of fluids entrapped in the crystals at the time of formation. And using the Bodnar equation of 1993, the last ice melting temperature of these inclusions had been calculated, which helped in terms of knowing the salinity of these two phases of saddle, two phases, which is saddle dolomite and vein filling calcite. So if you look at the salinity, it's around 20 equivalent weight % of NaCl, which is much more higher in terms of saddle dolomite, whereas around 15, maximum 15 equivalent weight % of NaCl for the calcite. Then it comes to the behavior of the reservoir properties in terms of various species, that how these various species correspond to the porosity permeability distribution. So if you look at this particular figure, I need to enlarge it because it is not very much clear. Sorry for this. So if you look at this particular figure, where we have porosity versus permeability signatures, it shows that the facies, which is represented as partially dolomitized mudstone facies, that has higher porosity and permeability signatures values as compared to the other facies, like the grainstone facies, like if you talk about the bioplastic grainstone facies or the Pell bioplastic grainstone facies, which are having almost negligible porosity in terms of its porosity and permeability distribution. So it indicates that the more finer the facies is, it has more porous and permeable nature as compared to the coarse-grained facies like the grainstone facies being observed in this particular outcrop. This is the model of diagenetic stages, which represent that how these facies, this particular limestone had been evolved with time. So we have divided it into three particular stages, where the first one representing the marine settings, where we have the mechanical compaction, cementation, followed by the burial, resulting in the formation of stratiform dolomitization. Then it is the burial dolomite is also responsible for the patchy dolomitization, as well as the patchy replacive dolomitization, and the last stage is representing the uplift, which is associated with the de-dolomitization and the late stage calcite cementation in these successions. This is a hypothetical model for the dolomite dolomitization of this Middle Jurassic carbonate succession, where we can see that in the earlier stages we have the initial stage of evaporative radiative phenomena, which results in the formation of earlier phases of dolomites, whereas the saddle dolomite and associated high temperature calcite, they are being formed by the fluids which have been driven from the much deeper sources. These are the two publications which had been published from this particular study so far. One is is the Facies control on selective dolomitization and its impact on the reservoir heterogeneity, and the second one is in carbonates and evaporites, which is associated to the diagenetic evolution and associated dolomitization events in the Middle Jurassic Samana Suk formation. So this was about the study of Hamad, who has just completing his PhD work and ultimately going to finish his PhD. Then we go to the other OUTCROP studies, which had been carried out by various master students in the same area, with some more field observations and the geochemical as well as isotopic analysis being carried out. This is one of the OUTCROP in the study area, where we have in this Google Earth map, we can have these 4 localities which had been logged, and these were studied in detail. This is the panoramic view of the OUTCROP, where we have thick dolomite bodies being present in between the limestone, and the limestone is these dolomite bodies representing peculiar different character as compared to the limestone. So here we can see the clear difference between the dolomite and the limestone, where the limestone is off-white to more light gray in color, whereas the dolomite is more dark gray in color. Similarly, we can further distinguish various dolomite types as well. Like over here, we can see a clear contrast between very dark gray colored or dark to blackish colored dolomite, and the light gray colored dolomite can be seen over here. Similarly, fracture filled calcite can be seen over here as well, which is indicating that they are cross-cutting the initial phase of dolomites and some earlier fractures which are being filled by dolomites as well. More inside view of that particular fracture filled calcite we can see over here, and another set of fracture which had been filled by the dolomites. So cross-cutting relationship indicate that within the dolomite, initial phase of dolomite, we have multiple and late stage dolomite fracture filled dolomites, and these are being cut by the late stage phenomena of calcite fracture filling. Similarly, the isolated pores are wugs. They are being filled by this brown colored dolomite, whereas in the middle we can see that white to off-white colored calcite. More inside view, where we can see that the 2 different dolomite bodies, dark gray colored and light gray colored, whereas we have the intermediate pore spaces are being filled by this off-white color, I would say, are more yellowish colored dolomite, which is known as saddle dolomite or yellowish colored dolomite. Similar examples we can see over here, that we have some bedding pellular dolomites, bedding pellular styrolites, sorry, we can see over here. Then we have this fracture filling dolomite, which are cross-cutting the earlier form dolomite as Dol1, and we can see some excellent fracture filling or brecciation phenomena which can be observed over here as well. This is typical example of this off-white color calcite, which can be seen in figure E. Brecciation is quite common in this particular outcrop, where we can see in multiple cases where the brecciation can be observed. The typical example, the host limestone, which is oolitic in nature, and that particular behavior is characteristic feature of Jurassic Samana Suk formation in the study area. Then we have these twin calcite, which are basically filling the fractures or the pore spaces, and we can see that the stylolite, the microstylites, which are being observed in this particular case as well. Similarly over here as well. So, and here it's the dolomites which had been seen of multiple phases or multiple generations can be evident as well. This is a typical example of the occurrence or presence of the original fabric, like in figure C and D, where we can see that the oolitic nature had been preserved, whereas it had been modified by the dolomite formation. And we can see that in figure A and B, we have these dolomite rhombs which had been the boundaries of these dolomite rhombs are being obliterated by the process of de-dolomitization, which we will see in the next slides in much more detail. Yeah, so this is the comparison chart, that how we can see the normal photomicrograph and the CL, and how they can differentiate, and we can be able to see and clearly observe that within the dolomites, where in C and D we can see that the dolomites are being the intergranular spaces or intercrystalline spaces are being filled by the calcite, which is representing quite bright luminescence over there. Whereas in A and B, we can see that fracture filling calcite, which is representing non-luminescence luminescent behavior, that can be evident as well over there. Whereas in figure E and F, we can see that the brecciation is quite common in these two photomicrographs, where it is quite evident in figure F, where the brecciation followed by the filling up of the open spaces by the very bright luminescent calcite can be seen over there as well. So these various phases, they had been collected, they had been sampled, and they had been analyzed for the oxygen carbon isotope analysis. And based on the carbon isotope analysis, it had been seen that the saddle dolomite has been having very high, very depleted values in terms of oxygen, whereas the Dol 1 is quite close to the original marine signatures. So we group them, that how they behave. So we, on the basis of groupings, we can see that these four different phases representing distinct signatures in terms of oxygen and carbon isotopes. Detailed paragenetic sequence had been established, which indicate multiple processes like cataclastic deformation, activation of fractures in the earlier stages, followed by the dolomitization during the mesogenetic stage, and then we have bedding parallel stylolites, which is again related to the burial, and then the cataclastic deformation, whereas some white calcite. There is some error over there. These two phases should be over here, that is linked to the burial related phenomena, whereas the rest of the dissolution, dolomitization, and the transparent calcite is linked to the late stage diagenetic phenomena, which is telogenetic in nature. Now it comes to the third outcrop, which is bedding parallel dolomites. Again, we can see vertical beds of dolomite and limestone, and these vertical beds representing interbedded limestone and dolostone succession in one of the studied section. Some typical example of the oolitic limestone we can see over here in the outcrop, and that represent the typical character of the Jurassic Samana Suk formation, where we have the occurrence of these limestone succession. Micritic limestone can be seen over here. Then we have clear contact between the limestone and the dolostone, where this dark gray color is representing the dolomite and the limestone over there. So I will just go a bit fast so that we can see that how these different these outcrop features represent various phases of dolomites and calcite. These are the various fracture filling dolomites where they are being affected by multiple sets of fracture related displacement. We can see over here as well. Similarly, calcite filling and the replacive dolomites. Then we have the fracture filling dolomites, fracture filling calcite. We can see over here. Some typical example of the styrolites being observed within these dolostones, and ultimately the pore filling calcite can be seen over here as well. These are the photomicrographs which shows the presence of various calcite and dolomite cements. Typically over here we can see that replacive iron-dominated, iron-rich dolomite, whereas we have the pore filling calcite can be seen over here as well. There is another example where we have we can see that the dolomite is present within the calcite. So this is very nice photo micrograph where we can see a very big crystal of dolomite is being present within the calcite, and that particular dolomite crystal has been affected by the process of de-dolomitization as well to some extent. Similarly, over here we can see some calcite cements and the replacive dolomites been present on top of it, and some saddle dolomite been present at the bottom. Various phases of the replacive dolomites. So just skip the most of the phases what we have already discussed. Some medium to coarse grain subhedral dolomites we can see over here. This is again the phenomena which we already talked about, that how the rims of the dolomite, they can be replaced or they can be affected by the process of de-dolomitization whenever we have calcite cementation in between. So that is been confirmed by the CL photomicrograph, where we can see that the calcite in between is responsible to have de-dolomitized these dolomite crystals in this particular CL photomicrograph. Similarly, over here, coarse crystalline ferrone dolomites, which are mostly we can see that in between these dolomites we have the calcite, which we can be able to observe based on the staining of this particular sample. Then the multiple sets of fracturing which had been filled by the calcite as well as the dolomite. So this is one set of the fracture filled dolomite. Then we have the calcite filling that can be observed over here as well. Some saddle dolomite cements can be seen over here, typical of this this particular type, which indicates the presence of saddle dolomites. Over here, we can see a nice undulose extension of the saddle dolomites, whereas at the bottom we can see these replacive dolomites being present as well. Then the twin calcite, quite evident again, the same calcite which had been placed within the dolomite, within the same dolomite which has been present within the calcite, the twin calcite. Multiple stages of fracture filling, like the earlier stage of calcite that had been cross-cut by the late stage calcite, which is indicative of multiple stage calcite phases being present over there. Then we have the growth of these dolomite along the fractures, where the fractures are being filled by these partial filling of the fractures can be observed over as well. Pyrite, specifically from rhomboidal pyrite, can be seen over here. Then the styrolites are quite dominant in this particular rock, as we are observing them throughout the studied sections, as we have seen so far. Sorry. Then a detailed paragenetic sequence had been given for representing multiple events of dissolution followed by mechanical compaction, then the RD2, which is medium to coarse anhedral dolomites, then the mesogenetic stages, and then finally we have few of the telegenetic events in the form of rhomboidal pyrite and D-dolomites can be seen over here as well. Isotope data, again, it is almost the same what we have discussed in the earlier outcrop studies, and they represent the same mechanism in terms of the behavior of different phases, like the saddle dolomite, which are enriched, depleted in delta O18. Similarly, the calcite, late stage calcite, that also represents the depleted signature of delta O18 as well. So this is a conceptual model where we have initial phase of limestone formation followed by the earlier phase of microtization, compaction, and then the fluid movement along the fractures, resulting in the formation of saddle dolomites, and ongoing burial results in the formation of these replacive dolomites as well as the saddle dolomites. This is the another conceptual model based on the geology of the area, where these various faults being present in the study area may have acted as a conduits for the upwelling of the fluids to form these high temperature dolomites as well as the calcites. So yeah, that's it from me. The conclusion is that the various dolomite bodies which had been studied during these 4 different outcrop studies indicate multiple phase of dolomitization, where we have initial phase which is linked to the marine signatures, marine waters, more close to the evaporative model, and then followed by the more fracture related saddle dolomite formation, which is associated with some deep source which had been which may be the fault related dolomites in case of saddle dolomites had been formed in this particular case. So this is the conclusion of this particular studies, and with this I conclude with the so that if we have any question on the from the audience, so we can take them.
Thank you, Mumtaz,
Yeah.
for this nice presentation.
Thank you.
As you said before, some of the pictures are quite similar to the ones that one they have to show.
Yeah.
And they could be from Benicasima.
Yeah, exactly. Some of the outcrop, they are quite similar to the Maastricht basin.
Yes. Well, let's see if someone from the audience want to ask something. Yes.
Harun, your mic is mute. Please unmute the mic. Yeah.
Okay, thank you very much, Dr. Mumtaz, for arranging this session and for a very nice presentation, sir. So in your opinion, which phase you think is the main destruction in terms, if we talk about the reservoir, in your opinion, which phase you think is the main destruction to the porosity that could be a good reservoir if Samana Suk formation was not exposed, or what event you think is the main turning point of this formation?
Thank you, Harun. In fact, we studied in one of our studies. We looked at the Facies control on the dolomitization, and we observed we linked this to the reservoir properties as well. So the conclusion of that particular article, which I had shown you, if I go back to the slide where we have these two of the presentation, two of the articles. Yes, if you look at this first article, Facies control on selective dolomitization. So this studies indicate that the mudstone facies, they have the porosities, they have the permeability, but the grainstone facies, they are being occluded by the calcite. So the late stage calcite, which is the white calcite, is basically the phase which occlude or destroyed the porosity in terms of this particular Samana Suk formation. So we believe that the late stage calcite as well as the saddle dolomites, they played a key role in terms of destroying the porosity of these reservoirs. So, and it is evident in some of the outcrop photographs as well. So if you look at like here, we can see that here we can see that the pores are being filled by the calcite and these dolomites. So in our understanding, it is believed that this late stage calcitization, which is highly depleted in terms of oxygen, as well as the saddle dolomites, they played a role in terms of occluding the porosity and permeability of these reservoirs.
Yes, thank you very much.
Yeah, Nasir.
First of all, Dr. Mumtaz, I would like to thank you and your team for arranging such a nice conference, such a nice and informative conference. And then, by the way, I would like to answer questions regarding the origin of the fluid, that the iron magnesium rich fluid that have caused the dolomitization in the Samana Suk formation. So is there any specific origin, that either the origin of the magnesium rich fluid was from the closed system, or it was an open system?
Nice question, Nasser. In fact, there are what we believe that there are two possible sources of dolomitization in these succession. The first one, which result in the matrix dolomite in the earlier phases, which have similar signatures that of the marine sea level, marine sea water. So that had been formed because of the some initial phase of dolomitization, and that is linked to the some evaporative model, whereas the late phase dolomitization, which is associated with the saddle dolomites and some replacive dolomites, they are being linked to the some external source. Some basement derived fluids are responsible to form these dolomite bodies. So multiple dolomitization fluids are suggested for the formation of these dolomite bodies.
Okay, and one thing more, that generally we have much more dolomitization in the Jurassic Samana Suk formation, but normally we don't have such phenomena or such dolomitized bodies in the overlying Cretaceous Kavagar formation. So is there any reason that why we have more dolomitization in the Jurassic Samana Suk formation while less in the overlying Cretaceous Kavagar formation?
Yes, you're right that we have the overlying Kavagar succession of the Cretaceous that had been pure limestone. So whereas the Jurassics, they have been affected by the dolomitization quite extensively. So maybe the reason behind it is that the timing, the geological timing in terms of fluids being responsible to dolomitize the succession were quite extensive during that Jurassic time as compared to the overlying Cretaceous succession. Maybe some other reason can be also, but this is what I can understand.
Okay, thank you so much.
Yeah, thanks. Yes, I think no more. It's it's about 8 o'clock in the evening here in Islamabad, so you can see people will be much tired. Huh?
Yeah, here in Belgium still it is early, it's late afternoon.
Yeah.
Okay, thank you.
So thank you so much, everybody. We have to conclude this particular session, extensive session, I would say, from morning till evening. So I'm extremely thankful to all the participants, and especially the presenters. Professor Rudy Svennen, thank you so much for giving us time. Dr. Juan Martin, thank you so much as well. Dr. Alessandro, thank you. Thanks a lot for joining us. Professor Anna, thank you so much as well. So it was very nice to see you all in this difficult time of COVID, but we made it, and it was nice that we were being able to organize this nice session, and it is all because of your contribution, your energies behind this. And again, I'm extremely thankful to all of you.
Okay, thank you, Mumtaz.
Thank you
to you, Mumtaz.
Thank you. We'll be in touch, and hopefully the geoscientist community here in Pakistan will get benefit out of today's session. Yes. Thank you once again.
See you soon, everybody on the field.
Yeah, see you in the field. Yeah. Thank you, Rudy. Thank you so much. Bye.
Bye.
Thank you, Wandi.
Thanks to all. Bye-bye.
And Anna, thank you so much. Bye-bye.
Thanks.
Bye.